8.5 is properties of logarithms. Oops. Okay. Now, before we get into that, we're actually only going to do 3 properties today. Before we get into that, 1 second. Hi.
Spencer? Get out of here.
Okay.
Thank you.
Yep. All right. Remember, if I have log base b of y equals x, what's another way I can write that? Or what's the inverse of that? B to the x equals y. Or Mitch said it, y equals b to the x, right? Because what you're asking yourself when you're trying to solve this is this to what power equals y, right? Okay, so if I had log base b, or excuse me, base 5 of 125 equals x, what does x equal? What is log base 5 of 125? 3, because 5 to the x, struggling here, that would have to be a 3 to get to 125, right? Okay, so just a quick refresher on that. Also, what happens if I have this scenario? Essentially, they cancel out, and I'm left with x plus 2, yeah. Okay, so just keep those things in mind. You're still using those. Okay, you still might have to use those. So just be aware of all that. Okay, starting today, we are going to have a product, a quotient, and a power property, just like you have with exponents, but they're going to be logarithms. Okay, the first one is your product property. Product means multiply. Okay, so what we have here is log base b of u times v is actually equal to log base b of u plus log base b of v. Your real reason why this works is because these, you're looking at basically exponents, right? This would give you the exponent on top of b, right? Because it's always equal to your exponent if you switch it around. Okay, so the main idea is if you're basically multiplying exponents, which means you add. Okay, but that's just a good property if you just want to simplify things down and solve in easier ways. We can use this. Okay, and sometimes you're not going to have a choice. You're going to have to use this, which will be most of your cases today. The second one is your quotient property, which means you are and how this followed along with our exponents. We were multiplying, so we added. If you're dividing, you're going to subtract, exactly. So you actually have the log base b of u divided by v. How do you subtract, though? Do you do v minus u or u minus v? U minus v, good. So you have log base b of u minus log base b of v. Notice the top went first, right? Okay. Okay, so that's your quotient property. Your power property is a little bit different. Did everybody have that? Okay, so you have log base b of u to the n power. We've been doing a handful of these. We've had things like, I don't want to write on there because it's not on the camera. Maybe you have log base b or base 5 of 5, or let's not do that, of 25 to the x. Okay. You can now use this property and rearrange that if we needed to. Okay, so we've been doing a lot of things that we could use this on, we just haven't used it yet. This changes into n times log base b of u. So basically you pull the exponent and put it where? At the beginning, in the front. Gotta remember there's some. Okay, before I do the examples out of example 1, I want to look at a couple different things. Actually, let's do those ones first, and then we'll look at the other things. Okay, so the first one, I'm not going to do the problems that you have. Okay, but they tell me that log base 9 of 5 equals 0.732. Again, that's probably not something that you could have came up with. And log base 9 of 11 equals 1.091. And then they're going to give us a few things they want us to evaluate. First one is this. What do you notice about this, Devin? It's got a fraction, so you're going to use quotient, product, or power property. Quotient, because it's division, right? A fraction means division. So I actually have log base 9 of 5 minus log base 9 of 11. Well, we know what these equal, right? So we can plug it straight into our calculator. 0.732 minus 1.091. And what do I get? .3 what? Again, it's not something you could have came up with if you didn't know those top two logarithms, right? Okay. I'm going to take this and just move it down out of our way so we can do the next one and still see those. Okay. The second one they have for us is log base 9 of 55. Now that doesn't have either of those numbers in it, does it? But what do you notice about it? 55 is actually what? 5 times 11. So I actually have 5 times 11 here. So I do what with log base 9 of 5 plus, good, log base 9 of 11. That's our product property. And I get what? 1.823, is that what you said? Okay. Does everybody see why we change this to 5 and 11? Because if you didn't, then you'd have no way to solve it. Because we only know log base 9 of 5 and log base 9 of 11. So we've got to switch it so we have it, right, Devin? Okay. And last one out of this group of problems, I have log base 9 of 25. Change the 25 to what? 5 and 5. Or you could change it to, did somebody say 5 squared? Yeah, you could do that. Okay, so you actually have, using the the power property, how would I rewrite this? 2 log base 9 of 5. Well, that'd be 0. Or sorry, yeah, 1.464. Sorry. Okay. You could have also, and the way I was actually going to do it, I was going to do log base 9 of 5 plus log base 9 of 5. Would that be okay? Yeah, it would. This is probably a little bit quicker. What did you guys cook in foods today? Oh. I thought I smelled bacon. Okay, questions on that so far? Alright, I do want you to be careful. Be careful of scenarios like this. They give us they don't give us any information. They say use a property of logarithms to evaluate the expression. They give me log base 3 of 9 to the 4th. Okay. Can you rewrite this in some way that is nice and easy for us? What can you change that 9 to? Yeah, you can change it to 3 squared. So you have log base 3 of 3 squared to the 4th. What happens? So you get... Now be careful. It's 2 times 4 because this is a power of a power. So 8. Okay, just be aware of that. Because this is actually equal to log base 3 of 3 to the 8th. Because I have power of a power here. And then those cancel. Right here. See what we did, Jedediah? I changed the 9 into a 3 squared. But then here you have a power of a power. So you multiply your exponents. So you have log base 3 of 3, but now it's to the 8th power. Okay. Alright. Looking at example 2 and 3, we have to be able to use these properties, the product, quotient, and power, to be able to expand a logarithm and condense it. Not necessarily solve it all the time, so you might not be able to solve it, but we want to be able to expand it and condense it. So I have log base 5 of 2x to the 6th. Okay, I want to expand this as far as possible. So expanding is getting longer, right? So I want to make this as long as possible. It's like when you have things factored out, it's like foiling and getting it together. You're making it longer. Okay, so first thing I notice is something about my 2 and my x. What's happening there? There is 2 of them, but what are they doing to each other? Yeah, it's 2 times x. So I can use which property? If I'm multiplying. Product. So this can be split into log base 5 of 2 plus log base 5 of x to the 6th. Can this go any further? Does it have multiplication? Does it have division? Does it have an exponent? So you're done with that. Does this have multiplication? Does it have division? Does it have an exponent? Yes. Okay, so we're not done here. So I want to rewrite one more time. Log base 5 of 2 plus, what does this change to? 6 log base 5 of x. Okay, double check. Can I expand that anymore? Can I expand that anymore? No. So you're done. Okay, we're making them longer. So then condensing would be doing the opposite, right? It'd be taking something that is already long and making it smaller. Okay, so let's actually do the one that they have in the book because it's a little bit more difficult than the extra example they give me. That I have log of 6 where is that? Plus 2 log 2 minus log 3. Now, our order of operations, addition and subtraction are on the same level, right? Okay, so you just go in order. Okay, but before I do that, let's take care of this. Why do I want to do this one first? It's an exponent, right? So I have the log of 6 plus I actually have the log of 2 squared, which is 4, minus the log of 3. What do these turn into? They're being added together, right? Got to be careful there. That's where it gets catchy. If I add 2 logarithms together, it's because these 2 numbers are being what? Multiplied. Right? So it's actually log of 24. Oh, I didn't hear you say that. Minus log of 3, which is division. So you have log of 24 divided by the log of 3. Or excuse me, that's not right. You have the log of 24 divided by 3, which is log of 8. Not bad, right? What's the base here? 10. Good. We still had some confusion. I don't think out of this class. I think it was in the other class. If they don't write it, it's not 1. It's 10. It's a base of 10. Alright. Questions on any of that? We're going to stop there for today. We're going to do the change of base formula tomorrow.